Okay, good afternoon, everyone. I know I'm the last talk of the day and I'm keeping you from a drinks reception, so hopefully I can keep you entertained for the next 20 minutes or so. So my name is Colm Bowe. I'm actually trained as a natural scientist, working originally on alternative or underutilised crops, and I've started to veer towards broader sustainability of agriculture and into kind of the ecosystem service realm more recently. This is some work that I did alongside Dan van der Horst from the University of Edinburgh. So I'm going to break with convention because I'm not talking about an ESPA project. I'm actually talking about a project that was part of a Valuing Nature Network project. So the project, the work I'll present is part of the project that was the right value for externalities. This was a project that was facilitated by the University of Cambridge, their Institute for Sustainable Leadership. And basically what they did was to draw together business leaders and academics together to try and develop methods to find the right way to value natural capital externalities that were associated with the businesses. For people who don't know what an externality is basically something that an organization or a company creates, like an impact, or it can be a benefit that an organization or a company creates. But it doesn't directly financially relate back to the company, so it doesn't appear on their balance sheets. It doesn't appear, and it doesn't relate to them financially. So in terms of ecosystem services and natural capital, and in terms of what we were looking at impacts on the provision of the environment, or the provision of the environment to provide ecosystem services or natural capital. And the task, so there was a bunch of companies involved, and we were teamed up. Dan and I were teamed up with Saab Miller. And basically what they wanted us to do was to look at the impacts of their extension services through this project, Progress Through Partnership, on the national capital externalities from the barley farmers that they were working with. And so this was within India, in Rajasthan, and particularly we worked within Jaipur, within Rajasthan. All the work around this project was all desk-based case studies, although our project developed a little bit further than lots of the others, and so we were able to interview some of the farm extension workers as well, and I'll talk about that as we go through. Barley production has been carried out widely historically in this region, but traditionally that production's been for fodder use. So the feed varieties are being produced. And basically barley production in that area has diminished over the last few years, largely due to lack of investment, due to poor prices from the barley. But however, in more recent years, so in the last 15 years or so, there's been a domestic beer market that's developed within India, and that's of course driven the demand for barley production, and particularly rather than using the feed quality, the brewers prefer much more to use a malting quality. So it's led to a lot of investment in barley production within the region, and an introduction of malting quality varieties as opposed to the feed quality varieties that were being used before. And part of this investment was essentially Saab Miller's project. So basically, this Progress Through Partnership project was an extension project where they had 30 extension workers working with 6,000 farmers across Rajasthan. And they were providing or promoting the new malting varieties of barley to the farmers, but also giving them best agronomic practice advice in terms of production within those regions. So the first thing that we basically needed to do was to map out the agricultural system within the region that we wanted to work in. And we did that by working with the agronomic team within Saab Miller. And so what we wanted to do was we wanted to be able to define what the inputs were going into the system, and based on what inputs were going into the system, define the outputs and therefore the externalities, the natural capital externalities that were being created. Overall, our selection of externalities, to a certain extent, was limited by data availability. So, for example, although there is some pesticides going into these systems, we weren't able to get a good quantification of how much pesticides were going in, so we weren't able to include that. But it was also affected by trying to exclude pre-company impacts. So the company really only came into this region around 2006. This region was already an agricultural, widely agricultural region. So things like land use change and things like that we didn't consider because the area was largely agricultural already. In terms of the amount of the different inputs going into the system, we wanted to use local data because we wanted to try and be quite accurate. So obviously this was broadly a desk-based study, so we were constrained to a certain extent in that sense. So the first people we went to, and the first people we were already talking to about the agricultural system in the region, were the senior agronomic staff within Saab Miller. But what we found was there wasn't really full agreement between the agronomic team and some other teams within Saab Miller about the quantity of inputs that were going into the agricultural system. And so what we knew it wasn't feasible within the scope of this quite small project to interview the farmers themselves. What we were able to do was the company offered that we could interview their extension workers. So an external consultant was brought in and we were able to run focus groups with the extension workers that were working on the Progress through Partnership project. And so we were able to identify the different inputs. So of course we had the different types of fertilizers, and obviously that would lead to volatilization of nitrogen and production of nitrous oxide. We also had the agricultural system that barley is grown in. It's grown in the Rabi season, and it's grown alongside gram, mustard, and wheat. And within the dry season, within this region, all these crops are largely dependent on irrigation. So because they're grown within the dry season. So obviously we were able to quantify the amount of blue water, green water that was being applied to the crops, and therefore derive the externality in terms of depletion of groundwater. If you then, of course, combine the fertilizers being applied with the water, you get runoff leaching, and so you get nitrates and phosphates going into the groundwater and local water bodies. And because there's very little surface water within this region, irrigation sources are largely based on groundwater. So, of course, we also estimated the amount of fossil fuels the amount of fossil fuels that were used, and therefore the CO2 emissions that were being created to pump the groundwater up and to irrigate the different crops. In terms of the models or methods that we used for our biophysical quantification of the externalities, we wanted to keep these fairly simple. The reason we wanted to keep them very simple is because we knew the overall objectives of this project was to develop methods that companies could then carry on and continue to use after the project had finished. We also knew that our work was going to feed into a manual that the Cambridge group were creating called the Evaluate Manual. And in fact, our case study ended up being the lead case study within the manual. And we now think, or I hope, we have to check, that Evaluate Manual is now fed into the Natural Capital Protocol and fed through in terms of developing methodologies for valuing natural capital around business. So as I said, we wanted to keep the methodologies or the models we were using fairly simplistic, so they could be transferable within the company and also between different companies. So in terms of calculating the amount of nitrous oxide produced, we just used very simple conversion factors that were available from the IPCC Tier 1 guidelines, and then that was just combined with the quantification of different fertilizers that we knew were being applied to the crops from the Farm Extension Worker Survey or Focus Group. In terms of the CO2 produced from pumping the groundwater up to be available for irrigation, that was just basically a calculation based on the amount of emissions produced to lift 1,000 meter cubed of water 1 meter in height. And then that was then combined with the amount of water that was being applied to the different crops. The amount of water that was being applied to the different crops, we just used the water footprinting method along with CropWatt to be able to do that. Obviously, to use the water footprinting method and to use CropWatt, you have to identify crop coefficients and length of growing periods. And again, we got these from the literature, but only from studies that were carried out within similar agroclimatic zones to which we were to which we are working. And because it's slightly subjective in terms of selecting a KC value and selecting a length of growing period value, we also ran a sensitivity analysis just to make sure that the values we were selecting were robust. And then in terms of the grey water pollution, so the phosphates and nitrates running into the water bodies, again, we just use a simple nutrient loss rate that was 10% for nitrates and 1% for phosphates. And again, that was just combined with the amount of fertilizer application. And then we use the grey water footprinting method, which is just the amount of water that's required to dilute the amount of pollutant down to within legislative water quality standards, such as EU water quality standards. Okay, so we'd got to the point where we understood how we were going to quantify our externalities on a biophysical basis, but to actually look at the impact of how the extension workers, whether they were really having an impact on the level of externalities, we needed to develop some scenarios. So our original idea was to develop a historical scenario from a period before the company was within the region. So the company came in and the project started in around 2006. So we looked at the growing season before that as a pre-company scenario. And then what the idea was then to compare that against a company scenario where our data was derived from our farm extension worker focus group survey. And for the historical pre-company scenario, data was derived. So we had yield and cropping data from government or district level, Ministry of Agriculture, Government of India data. However, we realized Saab Miller works with 6,000 farmers in Rajasthan. It works with 3,000 farmers in Jaipur. And the population of Jaipur is actually 6.5 million people. So what we realized is actually the Saab Miller project was going to have very little impact on government or district level data. So therefore what we did was we used the district level data as a counterfactual, if you like, as a baseline to compare our farmers that are working with the company. So we had, along the same timeline, which we called the current timeline, we had a scenario for farmers not working with the company. And we also had, based on our farm extension worker focus group survey, we had a scenario for farmers working with the company. And so we were then able to identify the changes that had taken, the differences between the farmers that were not working with the company to the farmers that were working with the company. And we can see those differences in cropping area. So the farmers working with the company are producing a lot more barley, and that's offset by reducing the amount of wheat they produce, reducing the amount of gram they produce, and reducing the amount of mustard. And we were also able to identify that the urea application on barley itself, because of the farm advice, had also reduced by 18%. However, we kept the historical scenario in place because this gave us some idea of the general trends that were happening within the region that we could then compare our scenario against. And so we can see from the historical pre-company scenario, compared to the farmer not working with the company scenario, we can see also the changes in what farmers are choosing to grow over that time period between 2005, 2006 and 2012, 2013. And we can see that over that time period for the farmers not working with the company, they've are growing slightly more barley, they're growing less wheat, they're growing slightly less gram, and they're growing slightly more mustard. But if we compare that from the historical pre-company scenario to the company scenario, we can see that farmers, rather than just growing a little bit more growing a little bit more barley, because of the impact of the extension services, because of the farm extension advice, they're growing a lot more barley, so 21% more barley, and that's offset largely, well, to a great extent by wheat, but also to a certain extent by gram and mustard. And what we're also able to identify is over that time period, there's a general intensification of agriculture going on. So between the 2005-2006 growing season and the 2012-2013 growing season, generally within the region, and that's affecting both sets of farmers, both working with the company and not working with the company. Inorganic fertilizer has increased by 13%, and there's been a drop in the water table by 10 meters over that time period. Okay, so we now have our scenarios. We have our 3 different scenarios. We have our baseline counterfactual, which is farmers not working with the company, and we have our company scenario, which is farmers that are obviously working with the company. And if we combine our biophysical calculations with our scenario development, we can then see the difference in terms of the biophysical aspects, in terms of reduction in the externalities, or the change in externalities between the farmers not working with the company, or the difference in externalities between the farmers not working with the company and the farmers working with the company. And what we see is, we see in terms of greenhouse gases or CO2 equivalents, we get a 3%, a fairly, a notable but fairly small change between the farmers not working with the company to the farmers working with the company. Again, in terms of groundwater loss or blue water use, essentially, we also see a 4% reduction in terms of the amount of blue water or groundwater they're extracting to apply to the crops. And in terms of grey water, again, we see a small reduction between the farmers not working with the company and the farmers working with the company. But what we also see, along with these, is that farm advice also seems to have led, and we've had lots of measures of well-being, and I admit this is quite a crass compared to some of the ones we've seen today, but it was just some measure that we tried to use. But we also see a large increase in farm income from the farmers not working with the company to the farmers working with the company. And so overall what we see is a reduction, the extension services project has led to a reduction in has led to a difference in externalities with the farmers working with the company producing less externalities. But we've still got a historical scenario that we can then use to understand the general trends that are happening within the area. And so if we compare our historical pre-company scenario to farmers not working with the company, we can look at the general trends that are happening within the region in terms of the externalities being produced. So in terms of greenhouse gases, we see an increase in the amount of greenhouse gases being produced over that time period from 2005 to 2012. With grey water, we also see an increase over that time period. But actually, with groundwater extraction, we actually see a very small reduction in the externalities. So farmers, over that time period, although have intensified agriculture in terms of the amount of fertilizers that they're applying and in terms of the greenhouse gases they're applying, for some reason they haven't intensified in terms of irrigation. And that may be because they have some awareness of the water constraints that are within the region. And then if we compare that to what's going on in terms of the historical scenario to our company scenario, then we can again see over that time period, we see that intensification in terms of greenhouse gases. But actually that increase is 16% less with the farmers working with the company compared to the farmers not working with the company. The same in terms of grey water. So again, there's an intensification, there's an increase, but that increase is 31% less with the farmers working with the company. But however, with groundwater loss, between the historical scenario and the baseline and the farmers not working with the company, we see a small reduction. And that reduction is still there with the farmers working with the company, but it's actually 400% greater. And so, it could be in this situation the farmers are aware of those water constraints, and these farmers have been aware of those water constraints, and because of the change to barley are able to therefore further reduce their water use in that sense. And again, you had this intensification of agriculture, which has increased farm income between the historical scenario and farmers not working with the company. But again, we see that same increase in farm income, but it's actually 100% greater than with the farmers working with the company compared to the farmers not working with the company. Okay, I'm going to speed up. We basically applied some economic. So we now had our biophysical changes between farmers not working with the company and farmers working with the company, but we needed to add some economic values to that. We focused on quantifying externalities from the aquifer itself and in terms of quantity of water from the aquifer. And so we looked at the cost to all farmers in the region from increased pumping effort, which was valued at just under 4.5 cents per metre cubed of water. And then we also valued the cost to replace the dry wells due to the reduction in the water table because of the water extracted from the aquifer. And then in terms of carbon, so it's quite difficult to pick a carbon price. There's obviously a range of different prices out there, from marginal abatement costs, different social costs for carbon. And so we basically just picked one that would be, somewhere, so it's sits somewhere around the middle of what Toll's been talking about in terms of their review of the social cost of carbon, but it was lower than Stern and DEC's marginal abatement cost of carbon. So we just picked somewhere in the middle, basically, just to try and be representative. And then, of course, we've got our differences between farmers not working with the company and farmers working with the company, and we have a biophysical quantification, and we can convert those into monetary quantification. And so, yeah, so on a farm basis, so all of these calculations are on a 2-point-hectare farm basis. You have fairly small economic values, but remember the company is working with 6,000 farmers across Rajasthan, and if we multiply these up by 6,000, then the reduction in externalities due to the farm extension services works out at about $150,000, and similar for the greenhouse gas emissions, and then a smaller value for the grey water. But the point is when we look at how much Saab Miller are paying in terms of salaries for their extension workers, and the cost of that, of the 30 extension workers, we estimate it to be about $5,000 per year, times the 30 extension workers costs about $150,000. So what this is showing, if you consider the cost of these extension workers and the money they're saving in terms of reducing externalities, in terms of public costs, this is actually a profit-making exercise for the company, just in terms of reducing the externalities alone. And so, yeah, we did a number of, it was a small, but what we like to think like nice and neat study. So the various benefits of impact. So we identified there was lots of knowledge within the company that the company wasn't even aware of in terms of the knowledge within the extension workers. What we did identify was that with the farm advice, farm income increased dramatically. So one thing we have, suggesting that in cases where farm advice does rapidly, or where farm advice does hugely increase farm income, then it can potentially be an alternative to payments for ecosystem services, because the farm advice can, motivate, by following best practice based on the farm advice, the farmers are not only reducing externalities, but they're also increasing their income. And we found that the salary paid to extension workers is equal to the reduction of the externality of just the water, of just the groundwater externality. So extension services are providing a positive returns in terms of reduction of public costs. Sorry, and just to, okay, that's fine, thank you.
Just a few questions, because actually our session has come to an end. I think we can allow one or two.
Yes. Thank you for the presentation. Do you have any idea in terms of how much of this understanding and knowledge from SAB Miller has gone to its operation within India or outside India?
So we don't know for certain. We do know it's changed. So I've had an email from them to say it's changed the way they think about collection of data. So in terms of understanding what knowledge and data is within the company, they say it's changed the way they think about data and the way they collect data for their sustainability purposes.
Neil has a question back.
Okay.
The one thing I was sort of thinking, you showed that with the rise of barley production, there was a decline in some of the other crops. Yeah. One particular crop is mustard. Yeah. And I understand from my own personal experience living in this part of the world, mustard is sometimes considered to be staple kind of thing. So does it mean that within your estimation of the income, did you conclude that the expenditure they're incurring to bind those masters from the market.
So we didn't look at the wider food security issues around shifting from the crops that they were currently producing to changing that to barley. So in terms of subsistence basis, you're talking about. So in terms of subsistence basis, we didn't. It wasn't within the scope of the study to look at the food security issues around that. We'd assume with the increased income that would offset what they were losing in terms of subsistence from the, from growing food that they're using themselves. But it would be something interesting to look at in terms of what are the. So you have this shift in agriculture that comes potentially from a certain driver, and then what are the food security implications? Now I thought that myself as well.
Thank you. Yeah, we've seen from a few previous talks today that changes in agriculture can have a diverse set of impacts on farmers, and sometimes increased marketisation, cash cropping can lead to increased risk and uncertainty, and even some farmers drop out. So I wondered to what extent in the model it allows for people to be leaving farming. And those kinds of impacts.
It doesn't look so. It was very much it started off actually as a case study on a reasonably large project, and the intention really was to try these types of methodologies out and develop some of these methodologies with the businesses. With us, Saab Miller were very interested in the results. We were interested in the results, and so we took it a little bit further. But these are certainly sensible questions that you would, if you had the scope for a larger study, I think would need would be very interesting to start looking at.
Hello, thank you for your interesting talk. I was just wondering if there's other types of beer that are produced using different crops which are at competition with the barley-based beer, like sorghum or millet or based brews that maybe are homebrewed, and this could be actually a negative thing for households that are dependent on those beer revenues.
It's not something we came across in the study, so it's really not something I can comment on.
It's something that I was told was a big problem in South Africa.
Okay.
In the past, I was just thought it might be a problem here too, but.
Any other questions?
Just a very quick one. How representative do you think that the farmers were of the farming body as a whole, or were they very well-behaved farmers?
So this is the thing about using interviewing the farm extension officers. What really you would want to do is interview the farmers that are working with the company and the farmers that aren't working with the company to get a true reflection of what's going on. It was a desk-based study, so but from the data that came out of the farm worker focus group, we tried to link that back to other literature data on fertilizer application and things like that to make sure what was coming out looked like it was robust.
Okay, so the session has formally come to an end, but I think we can still have a bit of a discussion, as I promised earlier, because I know there were questions for the previous speaker as well. But yeah, let us carry on then. Yes.
Thank you for the talk. I was wondering about your Bayesian network process. If you have also shown your results to those communities or these levels that you actually work with in the workshops for the causal network development, have you shown them the Bayesian network, the final one, or have you shown maps? What did you do?
No, actually, we have still only preliminary results, so we have not come to the final results. We would like to do it with especially with provincial and national stakeholders, but I don't think we will be able to do it again with the villagers. Also, I don't. Well, it will depend on the funding of the project.
Paul. Yeah. Okay. Thank you.
Any other final reflections before we end the session?
I have one question for him. You have. If your results are mainly based on the change in crop and also in the change in crop practices, both things.
Yeah. So to a large extent the change in what the farmers are growing, but then on top of that, there's also some farm advice that's also having an impact in terms of some of the externalities as well. But it's probably to a larger extent the change in what they're growing rather than, but there is some effect from the best practice advice as well.
Which speaker?
The earlier speaker. I probably could not get it, but if you could explain a little bit of, I could remember in your presentation or in your model you were saying that there was implications for urban land use change, and even you were mentioning urban poor to some extent in that one. Would you just give us a little bit of insight into how these factors went into your model?
Concerning
concerning how you represented urban land use and in particular the changes to the ecosystem service for urban poor.
Yeah, no, the research, the project is focused on the rural areas only. So that's why we take the charcoal demand from the urban areas as an external variable, because we are not researching the urban areas. So the population trends for the future plan a future increase in population in Mozambique, and also a increase in migration from rural to urban areas. So that is supposed to create an increase in the charcoal demand, but we are not studying the urban areas.
Okay, just a last reflection from my side, and that's on the papers we had this afternoon, was how fast these global drivers are actually moving these days. So traditionally we're used to global drivers and processes being slow and local being fast, and I think the whole thing has been flipped on its head now. And if you look at what's happened in both case studies, it's actually what's happening in terms of globalization, and very fast globalization, that has filtered down to the local level and created profound challenges to local people, but also benefits. So thank you, and I think we should give all the speakers a very good hand. See you at the drinks.